Assalamu alaikum, dear students, and welcome you all for today's science class. Let's start with the talk of the day. And today's talk of the day is hard work pays off. Hard work means doing work that is difficult. When you work really hard, you get success. It does pay in the end, and you will definitely see the good results of your work. So focus on doing the right things with all your efforts and you will get the success. Means your hard work will pay off in the long run, right? As you know, students, we were discussing about different properties of metals these days. Do you remember the properties of metals we had discussed up till now? Students, we know that metals are unique. About 75% of chemical elements are metals. When we talk about metals, we are usually referring to chemical elements that are solid, hard, strong, durable, shiny, good conductors of heat and electricity. So word metal is a broad term. Do you know why gold is used in making jewelry? Why copper is used in electric cable? Okay, so next interesting property which we are going to discuss today is metals are malleable, right? Metals are malleable. Malleability is the property or ability of metals to be pressed or rolled into thin sheets, right? Metals are malleable. It means that they can be beaten into thin sheets when a force is applied on them with a hammer. And it is the property or ability of metals to be pressed or rolled into thin sheets. Some examples of malleable metals are iron, copper, aluminium, gold, and so on. Although metals are dense and strong, but they can be easily shaped by hitting them with a hammer and by converting them into thin sheets with a hammer, right? Students, a malleable material is one in which a thin sheet can be easily formed by hammering or rolling. In other words, the material has the ability to deform without breaking or cracking. A malleable material has the ability to deform without breaking or cracking when a force is applied on it. For example, you can take an example of aluminium foil. Aluminium foil in our kitchen is an everyday use of this property of metal. Aluminium foil is made from aluminium metal. And because of having malleable property, aluminium metal can be easily drawn into thin sheets, right? Aluminium foil, as you know, it is used for wrapping food. Yes, because it has the property to keep the food warm, right? You can take another example of malleable metal, that is gold. Gold is also the most malleable metal. It can be flattened into extremely thin sheets. It can be drawn into extremely thin sheets. Why? Because of its malleability. A single gram of gold can be beaten into a thin sheet that has an area of 1 square meter, right? Silver, platinum, iron, they are also the most malleable metals. Clear? Okay, now moving towards the next slide, malleable. The words malleable or malleability came from Latin word malleus, right? And what does malleus mean? Malleus means a hammer. It means able to be hammered. Malleability means able to be hammered without breaking it. Or you can define it a material that can be bent or pressed into shape. That material is malleable material. Now the question is, why metals are malleable? And to understand this, you have to recall the metallic structure. If you remember the metallic structure, then you know that metals, they are made up of an array of positive metal ions and a sea of delocalized electrons. Array means large number of metal ions, right? Metals are made up of an array of positive metal ions, mean metals, they are made up of large number of positive metal ions. And a sea of delocalized electrons are also present in the structure of the metal. Delocalized means, if you remember, I had told you that these are free electrons. Delocalized means free electrons. So this is the structure of the metal, that inside the metal, positive metal ions are present, and around these ions, sea of large number of delocalized or free electrons, they are constantly moving. When and these metal ions, they are arranged in layers, right? These metal ions, they are arranged in layers, as you see in this picture. They are not singly present. They are arranged in the form of the layers. And when a force is applied, layers can slide over each other. Only when we apply the force, the layers of these metal ions can slide over each other, right? As you know, atoms are tightly packed in a regular layer arrangement in metals, right? So when we hit a metal with hammer, or a force is applied to a metal from one side, the layers of atoms slip. The layers of atoms slip, right? Not only one atom slip, but the whole layer of atom slip or slide over each other from that side where the force is applied. As you see in these two figures, when the force is applied on one side, the whole layer of atoms slip or slide over each other, right? That's why we can say that metal does not crack or break, right? When you apply the force, the layers, they just shift upon hitting. The layers, they just shift upon hitting and rearrange themselves and rearrange themselves. And after that, the free electrons, as you see in this slide, when a force is applied on these metal ions, the whole layer of metal ions, they shift or slide over each other. And the free electrons or the delocalized electrons moving around them, they will also move along with these ions. They will also move and shift themselves along with these metal ions and adjust themselves around these metal ions or metal atoms, again in new position. Clear? These free electrons, they will also move along with metal ions and adjust themselves around these metal ions, again in new position, like this, as you are seeing in this slide, right? That's why we can say that metals are malleable, right? That's why we can say that metals are malleable. Okay, now moving towards the next property of metals, and that is ductility. Metals are ductile, right? Metals are ductile. Metals are ductile, that is, they can be drawn into thin wires, right? In malleability, I had told you that metals are malleable because they can be drawn into, they can be converted into, or they can be beaten into thin sheets. But what is ductility? Ductility means that the metals, they can be drawn into thin wires, right? That property of metal is called ductility. Ductile means metals can be easily pulled into thin wires, right? Examples: gold, copper, silver, iron. These are all ductile metals, right? Silver is highly ductile metal, right? Silver is highly ductile metal because it is very, very expensive. That's why it is not used in making electric wires, right? Silver is highly ductile metal, but you have seen that we do not use silver in electric cables, in electric wires. Why? Because the silver is very, very expensive metal. Instead of silver, we use copper, which is also extremely ductile. We use copper instead of silver because it is also extremely ductile and it is cheap also. That's why copper is used in making electric cables or electric wires, right? Okay, now moving towards the next slide. The word ductile. This word came from the Latin word ductilis. Ductilis means easily shaped. So ductility means easily stretched into wire, easily stretched into thin wire, thin long wires, right? Easily stretched into thin long wires. By applying force again and again, basically what happens with these metals, when we apply the force again and again, we can shift the layers of atoms of metals many times and make it stretch or convert into elongated and very, very thin wires, right? How we can convert a metal into long, thin wires? By applying force again and again. As you know, atoms, they are arranged in layers, right? So we can shift the layers of atoms. Not only one atom will slip or slide over each other by applying force, but we can shift the layers of atoms of metals when we apply the force on them. And these layers of atoms of metals can be shifted or can slide over each other many times. It helps to make them stretch or convert it into elongated and very, very thin wires. This ability to be drawn into thin, long wires is called ductility, right? And this is because of the ability of atoms, the ability of the layers of atoms to roll over each other into new position without breaking the metallic bond. Clear? Okay, now moving towards the next slide. Ductility, as I have told you, is the ability of material to deform or stretch into thin wire when cold, right? A characteristic of metal closely related to malleability is ductility, right? You have seen that ductility is the characteristic of metal which is closely related to malleability. In malleability, we can convert the metal into thin sheets by applying force without breaking them. In ductility, we can stretch the metal into thin wire by applying force without breaking them. So metals that are malleable, they are also ductile, right? As you see in the picture, how metals can be stretched into thin wires. When you apply the force, when you stretch the metals, how you can stretch the metals into thin wires. See here, by applying force, by applying strong force on them without breaking, without breaking. How we can stretch a metal into thin wires without breaking, right? So gold, silver, copper, these are all examples of ductile metals, right? See here the thickness of the wire. We can convert even this thick metal into very, very thin wires because of its ductile nature. Clear? Students, making electric wires starts with either copper or aluminum rod about 1 centimeter in diameter, right? If we want to make electric wires with copper or aluminum, we will use copper or aluminum rod of about 1 centimeter in diameter. The rod is then run through a machine that contains a series of pulleys which help to stretch and thin that rod as it goes through that machine, right? The rod is run through a machine that contains a series of pulleys, stretching and thinning it out as it goes. So, by the end of this process, 1 centimeter thick rod has been reduced to about 2 millimeter in diameter. So, in this way, we can convert or we can stretch a metal rod into thin wires, thin elongated wires by applying the force through a machine. So this is because of the ductility property of metal, right? So today we had discussed an interesting property of metals, that the metals that are malleable and ductile. As you know, that malleability means metals can be converted into thin sheets without breaking, right? And ductility means metals can be drawn into thin, long wires without breaking. And why does this happen? I told you, why does this happen? It happens because we know that atoms in the metallic structure are present very close to each other. Atoms, they are tightly packed in a regular layer arrangement in metal, right? So when we hit a metal, when we apply the force on the metal, then the layers of atoms slip from that side where the force is applied. Not only one atom will slip or slide over each other, but the whole layers of atoms slip or slide over each other, right? And that's why metals, they do not crack or break. Layers just shift upon hitting. And these layers then rearrange themselves, right? And the free electrons or delocalized electrons which are present around these metal atoms or metal ions, they will also move and shift themselves along with these metal ions and adjust themselves again around these atoms in a new position. Clear? That's why metals show this property, malleability, and ductility also, right? Okay, now if you have any query regarding today's lesson, you can ask now. Now it's time for question answer session. Are you ready for it? My first question is, what does malleable mean? My second question is, what does ductile mean? Next question is, why metals can be easily shaped by hammering? Next question is, give some examples of malleable and ductile metals. Now it's time for homework. And what is your homework for today? Your homework is that you have to do question answers of Test Yourself of unit number 3, page 32 of your textbook. You will think and you will write answers of these questions on your science copies neatly and properly. Clear? So this is all for today's class. Today we had discussed about malleability and ductility of metals. In next class, we will discuss about reactivity series. Till then, goodbye from my side and thank you all.